Hey guys, this is my practice problems video on substitution and elimination. So if you want further context on how I'm getting to these answers in these synthesis problems, watch my previous video where I break down strong and weak nucleophiles, electrophiles, and how that plays into substitution and elimination, because that will really help with these problems. If you already know how to do that and you're just here for the problems, I urge you guys to pause the video and work through these problems yourself, and then you can unpause and then you can see if we get the right answer. So these questions ask, identify the major and minor products that are expected for each of the following reactions. So first of all, let's look at this reagent. What is this reagent? That reagent is OH minus hydroxide. So that's a strong nucleophile and a strong base. So that's a strong nucleophile, strong base. So it could go towards E2 or SN2. We really have to see if it's a primary, secondary, or tertiary carbon that we're dealing with. And for this example, we're dealing with a primary, and that OTS is a good leaving group. Remember, we did a synthesis in the last problem, or in the last video, where we got to OH to OTS, which went from a bad leaving group to a good leaving group. So that's why you see that OTS. So that's a good leaving group. So it's either SN2 or SN2 or E2. And if it's primary, as it is in this example, it's going to be SN2. So for this one, you're substituting out that OTS and you're putting in that OH in there. All right, this next one, we're dealing again with a primary carbon, and we have another strong nucleophile and a strong base. Because again, you can take off that Na. That Na is a spectator ion, so we're dealing with negatively charged oxygen and a methyl, so negative OMe. Okay, and it's a primary, so this is either SN2 or SN1, but since it's primary and it's a good leaving group, it is going to be SN2. So it could be E2 or SN2, and we look at if it's primary, tertiary, or secondary carbon, and we decide from there. So you're just substituting out that halogen, that chlorine, in for the OMe. You could also show this as this as well. You could show that methyl group out like that, but I'll just leave it as Me. All right, this next one, we have ETOH. So what is this? We have that H, so we don't have any charge for this one, and it says we're adding heat. So this is a weak nucleophile and a weak base. And we're adding heat, and that heat is important because if we didn't add the heat, we could not do any synthesis. So you'll see in most of your problems that we need high heat if we're dealing with a weak nucleophile and weak base. And you'll get both products. So you'll get OET and you'll get a substitution product in the most substituted carbon. So you'll get an SN1 product and an E1 product. And I'm sorry, I've only been showing the major products for this. So if I want to add the minor products, if any of you out there are wondering, I wonder what the minor products would be. So again, this is major. And I'll show the minor here. This is going to look a little weird, but that's the only way. Or I'm sorry, let's see. One less. I added one more carbon. Something like this. So that's the minor product. This is the major again for this problem, and the minor, which depending on what your professor is like, you may not have to show, and this is the minor product. And these products don't have a major and minor because it's one of those weird examples. So for this one, this next one, we're dealing with a secondary, and I'll switch back to my normal color. We're dealing with a secondary carbon, because remember, this dash is still a methyl. So we're dealing with a secondary carbon, and we have OET minus. So this is going to be elimination. because it's a secondary. So if I want to write this with all the carbons allotted for, we get something like this once you take away that bromine. And then we have to look at, well, what is the most substituted on here? And it's this right here. So you can also show this as something like that. That helps you understand. And that methyl group is no longer a wedge or dash because it's not a chiral center anymore. So this is in the major product, if I want to keep doing major and minor. So that's the major product. The minor product will be an SN2 synthesis. So you'd have a wedge on the side and it'd be OET. So that'd be the minor. All right, this next one, we have a secondary carbon, and we're dealing with NaOH, which is again a strong nucleophile and a strong base. So what are we going to be doing here? We're dealing with a secondary carbon, and it's a strong nucleophile and strong base. Well, we just did a problem like that, and we did elimination. So that's the same thing we're going to be doing here. It's actually no, that's a secondary, yeah. And did I add enough carbons here? I believe I did. Let's see, we had 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we had one coming out on carbon 4. 1, 2, 3, 4. So something like this. Let me do the same color. Okay. And you can make it something like that because that's what it was shown in the reactant. So that's the major for that one. Let me write major right by it. And let me draw the minor as well. We're doing substitution. This would be a dash on the bottom of this methyl, and this would be a wedge. It's because they get switched around in substitution, and you would just be left with a primary alcohol group right there. All right, so that's this first one. It's just going through major and minor, and I'm sorry I didn't start with writing them. I usually just write the major product because that's the one most shown in the synthesis. This one is dealing with stuff that you maybe haven't seen before, so there's more fun reagents. So we have H2SO4, we have water, NaSH. So let's go through these ones as well, see what happens. Whenever you see H2SO4 and you have any kind of alcohol, that alcohol is going to go through elimination because that's just what their reagent does. And it's usually shown as concentrated H2SO4, but for this reagent, it's going to be elimination on the most substituted carbon. So that would be the major product. And I'll just show the major for these as well, because that's primarily what you're going to be writing in here. So now for this one, we have water, which is a weak nucleophile and a weak base. We don't have any heat that's added here, so it doesn't say we have any heat, and we do have a tertiary, so we have a 3 on that carbon. So you actually cannot do synthesis. I don't know if this problem forgot to add heat, but this would only work at high temperatures. So without that heat added, you cannot do synthesis for that problem. And that's only because it's a weak nucleophile, weak base, and it's tertiary, so that it needs those high temperatures in order to convert into a product. For this one, we have a, let's see here, we have a strong nucleophile. And this is not a base, it's just a strong nucleophile. And we have a secondary, but since it's just a strong nucleophile and it's not a base at all, that SH is just a strong nucleophile, not a base. We know that whether it's primary, secondary, or tertiary, it's all gonna enter SN2 or SN1 if it's tertiary. This one is secondary, so it's gonna do SN2. So it's gonna substitute out that OTS into that SH. So that's gonna be the major product. And you don't have to write a minor because there is no minor for this one, since it's just a strong nucleophile. All right, for this next one, we're dealing with a tertiary carbon that's attached to a chlorine, which is a good leaving group. LG means leaving group. And we're dealing with a strong nucleophile and a strong base. Remember, whenever you see negatively charged alcohol group, or whenever you see a negatively charged oxygen connected to literally anything, so in this case it's OET negative, it's going to be a strong nucleophile and strong base. So for this one, we're doing elimination because it's a tertiary, so we have to write our product with a double bond. So it goes on the most substituted would be on that side. So that's your major product. If I want to write the minor, we're just doing substitution. So you're substituting in that OET, would be the minor. Okay. Our next one, whenever you see this reagent, we do the least substituted carbon and we're doing elimination. So you never, ever, ever do substitution when you see tert butoxide, and that's what that T-BUOK means. You always do the least substituted carbon elimination. So what that means is that for this example, you have something like this, and it goes on the least substituted. So I kind of switched these carbons around because what the carbocation would show for this is something like this, because you took away that iodine and it would go on the least substituted. So it wouldn't go here, right? That would be the most substituted. It would go on the least substituted. So the answer would look something like this. And we're allotting the same number of carbons. We have 4 carbons total here. Or I'm sorry, we have 5 carbons total there in the reactant, and we still have 5 carbons just with a double bond and getting out that iodine. And one more slideshow, I guess you could say, so feel free to pause this as well. This just asks to identify the reagents you would use to achieve the following transformation. So instead of writing the products and they give us the reagents, it's kind of backwards where they give us the products and we have to identify the reagents we use. So for this one, we have a primary carbon and we're going from OTS to OH. So if it helps you to rewrite this OTS as any other good leaving group, like a chlorine, that's totally fine if that helps your understanding. But all we're doing here is SN2 substitution. So all we have to do is find a reagent that goes from whatever our good leaving group is into alcohol. So one reagent you could use is NaOH. And that's the only reagent you could use. I guess you could use, I don't know if this is really shown in books or if this is necessarily correct, maybe KOH. I don't know how different spectator ions react with, on an organic chemistry level. So I'll just leave it as sodium hydroxide. So sodium hydroxide, you can go from OTS, or if this was a chlorine or a bromine, you can go from that to an alcohol, primary alcohol. But how do you go from a bad leaving group? Remember, alcohol is a bad leaving group, so it can't really leave if it's a primary a carbon you're dealing with. How can it go to CN? Well, if you watched my previous video or you've been paying attention in class, you can change this into a good leaving group, this OTS. So you can do TSCl with pyridine, that PL, to make this go from, and I'll write the synthesis out here. Oops, kind of wrote that backwards. So when you react it with TSCl pyridine, it becomes OTS. And then from there, that is a good leaving group, so that OTS is a good leaving group. With that good leaving group, you can now go to CN, and what do we use here? We can just use NaCN. So our secondary step is NaCN. Okay. It's just substitution, so that one is pretty straightforward. All right, how do we go from alcohol group, and this isn't a primary alcohol, to a bromine? You can do this in one step. I know many of you are thinking, well, we can change this into OTS and maybe we can react it with tert butoxide to make it a double bond, and then we can have HBr. Well, you haven't really learned alkene reactions yet. So that will come in next chapter. But one reagent you guys have seen is HBr. And that's the one reagent you can choose to go from alcohol to bromine. Okay. This next one is just pretty straightforward. It's a secondary chlorine, and it changes into sulfur with an H there. So you can just do NaSH because it's just a simple SN2 synthesis. This would be the minor product, although the major product would be a double bond if you were to really do this. But if we're adding that SH is a nucleophile only, so it can't form into a double bond. So even though this is a secondary carbon, it can only do that substitution. If we're dealing with a reactant, let's say we dealt with NaOMe, then this OME that you would have right there would be the minor, because this is a secondary carbon you're dealing with. But we can just write NaSH for this one. And that is it for this video. I hope you guys learned something. I'll see you guys in the next one.